Welcome to this explainer. Today, we're taking that tiny, mighty Raspberry Pi of yours and leveling it up. We're talking about transforming it from a fun weekend project into a completely bulletproof, continuous operation powerhouse. Seriously, if you've ever pulled your hair out over a crashed app, a corrupted SD card, or a Pi that just randomly drops off your network, well, you're in the right place. We're diving into some hardcore benchmark data, engineering blogs, and community deep dives to totally revamp how you deploy these little boards. Here is our roadmap for Pi Mastery today. We'll start by choosing your perfect OS, look at the real-world performance of 32-bit versus 64-bit, cut the cords by going completely headless, explore remote GUI tools like VNC and X11, and finally, bulletproof your setup for true 24/7 continuous operation. Let's get into it. All right, part 1. Choosing your perfect OS and setting that critical foundation. You know, throwing a full desktop operating system onto a Pi that's literally just sitting there blocking ads or running home automation, it's like using a sledgehammer to crack a nut. It just chews through your precious resources. When we look at optimizing for resource-constrained setups, there's a wild difference between the incredibly tiny 400 megabyte DietPi and the 1.8 gigabyte Pi OS Lite. I mean, they're both built on Debian Linux, sure, but DietPi is hyper-optimized for pure minimalism. If you're building a custom server where literally every single megabyte of RAM matters, DietPi is an absolute game changer. But hey, if you just want maximum community support and that rock-solid out-of-the-box stability for a standard headless deployment, Pi OS Lite is your go-to. And of course, if you're actually building a desktop replacement, then yeah, go ahead and grab the full Pi OS desktop. Moving right along to part 2. Let's talk speed trade-offs, 32-bit versus 64-bit performance. For the longest time, the Pi community just naturally defaulted to 32-bit software, mostly to keep compatibility with older boards. But honestly, if you're rocking a modern board like the Pi 4 or 5, doing that is actively holding your hardware back. Looking at some hardcore Phoronix benchmark data, and they ran 128 different tests for this, the 64-bit OS delivered a massive 40% speed increase. 40%. And it won outright in 86% of the tests. That is a humongous leap. Whether you're running heavy databases or doing media encoding, making the jump to 64-bit really unlocks the true potential of those ARM v8 processors. And there's always a but, right? There's a trade-off here. That blazing 64-bit speed comes at a pretty hefty cost. It requires nearly double the RAM, jumping from an average of 456 megabytes all the way up to 873 megabytes. So if you're still running an older Pi with just 1 gigabyte of memory, forcing 64-bit might actually choke your system and cause bottlenecks. But if you've got 2, 4, or 8 gigs of RAM, 64-bit is a no-brainer. Oh, and a quick bonus fact from those same tests, there was literally zero measurable difference in CPU temperature between the two, so no need to worry about extra heat. Okay, part 3, going headless and simplifying your setup. Look, if you're building embedded systems or shoving your Pi into a tiny networking closet, physical peripherals are nothing but a massive headache. Going headless, which just means managing the Pi entirely over your network without any monitors or keyboards, is by far the cleanest approach for real-world automation. Seriously, no more hunting through boxes for a spare HDMI cable or unhooking your main keyboard just to type 3 commands. Once you power it up, you handle the whole shebang right from your main laptop. And the best part? The Raspberry Pi Imager tool does all the heavy lifting for you now. It lets you securely configure your Wi-Fi and SSH before you even do the very first boot. It used to be such a pain. You actually had to manually create empty text files on the SD card just to trigger these settings. Now, you just click the little gear icon or hit Ctrl-Shift-X right there in the Imager. Type in your Wi-Fi password, set up a secure username, enable SSH, and boom, you're done. By the time you pop that SD card in and turn the Pi on, it connects to your router completely on its own. Of course, since you don't have a screen attached, you might be wondering, how do I actually find my Pi on the network? Well, it's pretty easy. If your home network supports MDNS, you can literally just open your terminal and type SSH, your username, the @ symbol, and then your chosen hostname .local. That's it. If for some reason that doesn't work, don't sweat it. You can just log into your router's admin panel or run a quick scan with a tool like Nmap. It'll instantly show you exactly where your little headless computer is hiding. Moving to part 4, remote GUI tools and getting that graphical control. Now, command lines are amazing, but sometimes you absolutely need a window and a mouse. Now, standard VNC is fine, but it streams the entire desktop GUI, which eats up resources. X11 forwarding, on the other hand, is this super efficient trick. It lets you run just a single graphical app on your main computer while saving your Pi's processing power. All you do is use the command SSH-Y. That enables trusted X11 forwarding. So when you launch a graphical program from the command line, the window opens right there on your Mac or Windows desktop, like it's running natively. It saves tons of memory and, as the Element 14 engineering community points out, there's a massive bonus here: native clipboard sharing. You can literally copy text on your main PC and paste it straight into that Pi application. Talk about a workflow upgrade. And finally, part 5, bulletproofing for continuous 24/7 operation. This is where we leave the weekend hacking behind and step into true commercial-grade reliability. It is honestly magical to think about, but a well-optimized Pi can run digital signage or core servers for literally thousands of days without a single reboot. We're talking documented, real-world deployments in places like hotel lobbies and factory floors, hitting massive uptimes of 500 to over 1,000 continuous days. But listen, they didn't get there by just plugging the board into a cheap leftover phone charger and crossing their fingers. They specifically engineered for longevity. Which brings us to the absolute elephant in the room: standard consumer SD cards. Under constant read and write cycles, they will inevitably fail and crash your server. According to massive datasets from digital signage experts, a staggering 70% of all 24/7 Pi failures trace right back to the storage. Normal SD cards are made for digital cameras, guys, not operating systems. They simply wear out and corrupt your data, usually within the first year of continuous use. So if you want that 1,000-day uptime, you absolutely must follow what we call the 3 pillars of reliability. This prevents data corruption, voltage drops, and thermal throttling from ruining the fun. Pillar 1, swap out that cheap SD card. Get an industrial high-endurance card. Or honestly, if you're on a Pi 4 or 5, just boot directly from a USB drive or an NVMe SSD. It's a game changer. Pillar 2, power. Use an official or certified power supply. Cheap chargers cause these microscopic voltage drops that will silently corrupt your data over time. And Pillar 3, manage the heat. A Pi under heavy load will easily hit 80 degrees Celsius and start throttling its own speed to survive. Just slap on a decent passive heatsink. Or, if you're really pushing it, add an active cooling fan. That'll drop temperatures by 20 degrees almost instantly. So, I'll leave you with this. Is your current Pi setup reaching its full bulletproof potential? Or is there a failing SD card sitting in there right now, ticking away like a time bomb on your network? Take a hard look at your hardware today, upgrade those 3 pillars, and see just how far you can push your own uptime. Thanks for tuning into this explainer, and I'll catch you next time.